as many you've probably seen today, is predominantly focused to Git and GitHub, and that is obviously on purpose. Git and GitHub is the backbone to collaborative work in open source code, and so we want to spend all of the day on it to make sure that hopefully by the end of the day, everyone has a reasonable understanding of how it works, because it will be used extensively for the next following days. Git, which is a type of version control, can be a little abstract at first. I know when I did it, I had a hard time understanding it at first, and that's mainly because there's a kind of a ton of hidden connections that aren't very apparent right off the bat. And so once you can get the picture, for me at least, once I had the picture in my mind, is when I really was able to start understanding how everything was working. So I'm going to start off with a handful of slides, kind of doing an overview of Git, and then I'll hand it off to Nick to do a command line version of Git, and then he will hand it back to me, and I will do a version of Git through PyCharm, which is the editor that I like to use, and then from that we'll go on to GitHub. And unlike yesterday, where we kind of steamrolled through a bunch of material, today we're hoping to pause along the way and make sure everyone stays up to speed. So if you need us to slow down, or if you have any questions, please feel free to speak up, and we'll do our best to get you going. We'll do our best to balance it, because we don't want to be here for an extra 2 hours, but we want to make sure that everyone can follow along. So we'll do our best to keep it balanced and moving along, and keeping you all up to speed as well. All right. So what is Git? As I mentioned, it's a free open source version control system. So it helps you track changes to your code, helps you, here, PhD Comics says this well. I'm sure many of us did this with our dissertation, the old style, first style of version control. You write your paper, you copy it, you rename it for the next version, copy it, rename it for the next version, copy it, rename it for the next version, and then you forget which one you're on and which one you really want to do. And where was that change you made? And we've all been here. We've all been here. Luckily with Git, this happens less frequently, I think. So that's the point of Git. It's to have a system to allow you to track changes and merge and kind of keep control of everything that's happening. There are several types of version control out there. There's a Subversion, Miracle, CVS. There's a lot of different version control systems out there. The dominant one is Git. That's what we use for Plasma Pi. Most, not all, but most open source packages use Git as their version control. Okay, so whoops. To download Git, you can go directly to Git's website. This is for most Windows users, this is likely how you have to do it. You go to one of these links, and you can download Git and just install it. So Nick, can you launch the poll?
I hope so.
So I'm going to finish with these couple of slides, and then if we find out that people don't have Git installed, then we'll go through the process of getting you all up to speed. All right, so kind of a simplified cartoon of how Git works and some of the lingo associated. So a repository is the directory containing all of your files. you'll often hear us say repo, short for repository. So you can have a local repo or a local repository. That's the directory that's on your computer. You can also have a remote repo. That would be, say, a copy of that folder up on GitHub. So that would be remote repo. In that repo, you work on branches. These are lines of development. Typically, you have a main branch. So if you look at Plasma Pi, jump over here real quick. You'll see our main branch is named main. This is our default branch. You'll see some legacy code bases out there that use master. Master was the old term that's used, so don't get confused when you see both of them. They both generally refer to the default branch. So kind of new age naming scheme is to use main. So each of these little dots are what are known as commits. So you make a little bit of change, you like it, and you commit it to the Git system. So that basically creates a recording in time of the changes you made. And these are kind of like little breadcrumbs. So you can go back and look at them if you have a good version, either through the command line or through the IDE. You can go back and you can look at these breadcrumbs. Now, generally the way you work, you don't generally work on your main line of development. You like to make new branches. You make new branches for your IDE. You can make branches from your main branch. You can make branches from an idea branch. And so you pop out a branch and you can work on that. So you start off a main, pop up a new branch, say in this cartoon here, idea A, and that's a completely new branch, and you switch to that one and you work on that for a while. You make a couple commits, get your idea, and then if you like it, you go through a merge process. And what Git will do is they will bring these changes into the main branch. If that's where you're merging it to, you can merge to different branches, but generally you merge back to the main branch. So you merge that back into the main branch, and Git will do all the work for you to make sure that whatever changes happened on main and whatever changes happened on your idea branch don't conflict. If they do conflict, you have to go through what's called the merge conflict process to pick and choose how you want everything to end up in the end. So they bring these new changes into main, and we'll tag it with a merge commit. You can have an idea B branch that you never merge. You kind of, okay, this idea doesn't work, I don't want it anymore. You can let it be there, so you have a history of it, or you can delete it. And that's the basic cartoon of how Git works. Okay. So I think I'll just take a minute to ask if anyone has a question. Git can work. If someone asks, is Git bash? It's a set of command line tools, so it works in a bash shell, but it works in many shells, not just bash. Are there any questions? Okay, so as I alluded to, there's two ways to really interact with Git. There's the command line approach, which is what I'll hand this off to Nick to go through that. And then there's an IDE approach, which generally leverages a built-in GUI. That's very helpful for people like me who have a very hard time remembering the Git commands. So it looks like we have about just a little less than 40 people that don't have Git installed. Is anybody having trouble getting Git installed?
Yeah, this is Will, by the way. For anybody who is having problems, we could have a breakout session if you'd like to work on that.
Okay.
Nick,
Remi's did put the
you
link in
want
the.
to
Go ahead.
you want to end the poll and see if you can redo it, because it might be a little more updated now. I don't know if we have to copy it and redo it or not.
We can just relaunch the poll.
Oh, okay.
Yeah, but you might not allow previous users to read.
It'll clear the results.
Okay, never mind then.
So Remi's did put the link to downloading Git in the chat. I'll put that again.
Or idea is like how it works intuitively is like, let's say you write a really good program for graphing software, then you can make branches off your Git repository, and then you'll always be able to use your code that you wrote for graphic software. So that's kind of how the version control works. So you could use that little bit of code you wrote in all your projects, and you don't have to rewrite it many times.
Yep.
All right. I say ask one more time. Raise a hand if you need help with installing Git, and if we're good, then we'll move on to Nick. Sound good?
Sure. Let's see. Another option, I think for Windows users, but might be more broad, is to use Git Bash, which was brought up in the chat. And if you have trouble with the main Git thing, I'll put. So as an alternative, you can use Git Bash. Okay. So yes, if you have any questions about that, we have the help desk open in the Discord link, and then feel free to ask on the Zoom chat also. And I was going to put one more link in. Right, so what I'm going to go through is the software carpentry lesson on Git Novice. And so that is, software carpentry is an organization that does its best to help students and scientists learn the computing skills that we usually don't get taught in classes, and that we often have to learn on our own. And software carpentry is lessons on Python, the Unix shell, and Git and GitHub, as well as a few other topics that are more discipline specific, like R for statistics and psychology and things like that. So, okay. All right, so it sounds like most of us have Git installed, and
that percentage of people that didn't have it installed, what was that? Is that 36%?
It was just under 40, 37, if I remember correctly.
I would say that's a large percentage of people
now,
who don't have this.
Right now we have 7 people, so 18%.
okay.
That's the current poll.
Okay, of the 18%, do we know how many people want to have it installed before, like, want to actively participate, or are they okay with not having Git installed?
I think raise your hand if you would like more time to install Git on the Zoom thing under reactions.
Yeah, because we want one of the objectives is to make sure that we have active participation. Obviously, everybody, you're free to do what you want. if you just want to follow along. But we want to make sure if you want to actively participate, that you have the ability to do so.
Okay. So yes, please raise your hand if you would like more time. All right. So don't see any hands raised. So we can go ahead and proceed. So I'll try to share my screen. All right, that should be showing up. And
good.
is the font size okay?
Type a couple words, letters.
Does that show up okay?
Good for me.
Okay, cool. All right, so the first step to using Git via the command line is to open a command line terminal. So we can use what we did yesterday. For Windows users, that'll usually be Windows Subsystem for Linux if you installed it yesterday, or PowerShell, or Git Bash if you have that. On a Mac, go to Finder, Applications, and then you should find the terminal there. And for Linux, Control-Alt-Tab for opening it. So Windows Subsystem for Linux, Git Bash, or PowerShell for Windows. Finder, Applications, Terminal for Mac, and then Control-Alt-Tab for Linux. All right, so now that we've opened a terminal, we can make sure that we have Git installed. So we can type git -- version. And if you have Git installed and accessible, then you should get something like Git version 2.34.1. The specific version shouldn't matter so much as long as it's not like 1.1 or something like that. So again, please raise your hand if you need a bit more time. So I can't actually see who has hands raised right now. Eric and Will, if you could let me know if anyone has hands raised.
Will do.
Cool.
So if
Yeah,
you
it
have
looks
a
clear right now.
if you have a really old version, how do we update Git from here?
I think it should be okay if you have a really old version. If you wanted to update it, it'll depend a lot on if you are using like which operating system you're on. But most of the commands I'm going to show have been with Git for a really long time. So
I did find recently Git restore. Some versions of Git that we have on other servers don't have a Git that has Git restore in it, just for your benefit.
okay, I don't think I was going to use that, but
Okay. I love Git restore. That's
Okay.
one of my favorite.
all right. Okay, so now we can go ahead and get started. So now that we have Git going, we can let's see, configure it. So the first thing to do is say git config -- global, and then user.name. And then in my case, I'm going to say Nick Murphy. Hopefully spelling it right. And this is telling us, or telling Git, that for every time we use Git, that the username is going to be, in this case, me. I think I started the IDE poll accidentally, so I think I'm going to close that because that was for yesterday. So, all right. Still getting used to Zoom 2 years after pandemic started. So the next thing is to do git config -- global user.email. And then in my case, it's going to be NA Murphy at stuff. And you can put your email there. And this is going to sign every commit with my name and my email address. If you prefer to keep your email address private, later on when we use GitHub, there's a you can use the private email address that will be associated with your GitHub account. But in general, it's helpful to have the email address there because if you're contributing to a repository, the email address lets authors contact you again and ask if you, for example, want to be a co-author on a paper. So it helps to make sure that you get credit for the contributions. And the next thing is to configure for line endings. So the way that line endings are stored on Linux, Mac, and Windows is different. And so if you're on Mac OS, press Control+C there, or Linux, we want to do git config -- global core.auto CRLF input. Make sure that I have that right. And so that should be Mac OS. And oh, what froze? Okay. I think for git bash, if you reopen it, that's probably the best way to go about it. Right. And then on Windows, I'll press Control+C because that's not a command that we need. Git config -- global core.auto CRLF, and we can put true. So on Mac OS or Linux, do the first command, and then on Windows, do the second. All right. The next thing that we can do is to configure which editor we want to use as the default. And in my case, I'm going to use Nano, which is a terminal-based editor. It's often installed by default on Linux, but you can also use your favorite plain text editor for this. And you might be able to skip this step too if you aren't sure which one yet. So I'm going to do git config -- global core.editor and then nano-w. And the -w is related to word wrapping. Okay, and let me pull up the in the link I'm going to put in the Zoom chat, and also on the screen. Oops. If you scroll down a bit to editor, there's a table which has editor and configuration command. And if you, it's helpful to select your favorite text editor from that. And then usually you can copy and paste the command, but don't copy the $ beforehand, since that's the prompt. All right. One other thing that we want to do is to set our default branch name. Eric mentioned that the default branch name on GitHub and most other platforms has changed to main. And so we want to tell Git to do the same thing. And so that will be git config --global init.default branch and then main. So and then press enter. And so that will make our default branch into, that'll end up being called main. One thing to note is that the --global option is going to tell Git to do this for every repository that you end up creating or using. We can also look at the settings that we have, and that is with the git config --list command. I'll scroll back up again. And so this should have a few commands that we just put in. So it'll probably have your user.name, user.email, the thing about line endings, auto CRLF, and default branch. And there might be a few others that got set. I have a bunch because one of the ways that I procrastinated one day was to look up different ways to customize Git. So there are a lot of websites out there that say have some helpful customizations. All right. So that again was git config list. Oh, and one important thing is how to get help on with Git. So to do that, let's say we want to get help for the config option. We can do git config --help. So git config --help. And this will open up the help page, and we can press up or down to get a whole bunch of different commands and options and how to use it. And I won't go through these because there are a lot, but it'll show different ways to use Git, different ways to configure it. And then to exit this, I'm going to press Q. Control-C would also work. And even more generally than that, if we type git help, it will print out a message on how to use Git. So this was the command. And so we could do git --version, which we did earlier, --help for help. And then a bunch of other things. So this would be git add, git restore, which we'll just mentioned, and a whole bunch of other things. And we're going to cover a few of these today, the ones that are used most often. Okay. The next thing that we want to do is to create a repository. So let's do cd ~/desktop. And if you're not used to Unix, the tilde is a shortcut for your home directory. On Windows, I think it might be the / the other way. But for WSL, it should be like this. So once we get to our desktop, I'll press pwd, a Unix command for print working directory, and shows that I'm in the desktop. And now I want to make a directory. So I'll do mkdir, and let's call it planets. And then we can enter the directory with cd planets. And then I'll do pwd again because I always do that to help keep track of where I am in the terminal. So again, we wanted to make a directory, planets, and then enter that directory in planets. The way to initialize a Git repository is with the command git init. And so we can do that now. And it says that I initialized an empty Git repository in for the directory that I'm in. And the what this did is, so let's do ls-a, and in that it's showing a new directory called .git, a new hidden directory. So we do regular ls, this won't show up. What is contained within the .git directory is the history of the repository. So all the information for the commits, branches, everything is stored within the .git directory. And in general, we should not do anything within that directory manually. We should use git to do everything. If we ended up deleting this directory, then we would make this no longer a Git repository. We would lose all that information. So the .git folder is important. All right. So now let's change the default branch to be main. So let's do git checkout -b main. And so what this did was two things. First, it created a new branch and called it main. And that's what the -b flag here did. And the checkout command ended up switching us to this branch. So we created a new branch called main and switched to it. A branch is essentially a kind of like a development path. In the software carpentry tutorial for the next bit, we're not going to use branches all that much, but they're a way to record a different history, a different path that the program, the code, is taking. So, right. The next command that we can do is git status. All right. And git status is a really important command. In practice, usually 40% of my Git commands are git status. They tell us where we're at. We're on branch main. In this case, we don't have any commits yet. We haven't recorded anything to the history. And we haven't created any files for the repository, so there's nothing to commit. And if you're using a different version of Git, the output might be a little bit different. But again, git status is a really helpful command. And if you're coming back to writing code in a particular directory, typing git status is a really good way to remember what you did last time. So that's why I end up using it really, really often. Okay. So I'll pause here for a moment in case there are any questions. And feel free to raise your hand or bring it up on Discord also. All right. The next thing we're going to do is talk about how to track changes. And the main things that we want to do are the questions that we want to ask are, how do we record changes in Git? And how do I record notes about what changes I made and why? So we're going to go through the cycle of making a change, modifying a file, adding that, and then committing it. So that's the main cycle that we use for Git. So we should be in the planets directory that we just created. So pwd, and yes, we're still in planets. And then the next thing we're going to do is to open a new file. And in my case, I'm going to use nano to open mars.txt in this. If you prefer, you can use whichever text editor you like. So you could change this to Emacs or VI or Vim or Notepad. Or if you went to the folder and then right-click or command-click and do create new file or new text file, that should also work. So I'm going to use nano, and you might be able to also. And so this opens a new file, and this is called mars.txt. And say that Mars is cold and dry, but everything is my favorite color. All right. So I created this line. What do you put in it? Doesn't have to be specifically this. And for nano, I'm going to do Control X, and it says save modified buffer, and then I'll press Y to confirm that, and enter to say mars.txt. So let's do ls. And we have a new file here, the one that we just created, mars.txt. And then let's use one other Unix command called cat, which is short for concatenate, and then also do mars.txt to make sure that, so what the cat command does is print out the contents of the file. So the contents of mars.txt is this line. All right. So let's run git status now. Git status. And so we see that we're on branch main. We have no commits yet. And we have untracked files. And the untracked file is mars.txt. Let's see. So a couple commands in the chat. So how do I exit mars.txt? Control X isn't executing. So that might be if you opened it with, did you open it with nano? Okay. Let's see. So I'll do this again. Nano mars.txt. And from this line, it should be Control X. If you're on a Mac, it might be Command X. Actually, double check that. Windows. So that should be Control X. let's see. So control, you got it? One of you got it? Okay. So control X and then Y for yes, and then enter. And I think that was the steps. Okay. Yes, please stop me if there are any steps where needed a bit more time. Okay. So we just did git status. We're on branch main and we have no commits yet. So that means that we haven't taken any snapshots of the repository. We haven't taken any snaps. We haven't recorded any changes yet. We changed a file, but Git is not tracking that. But Git does helpfully tell us to use git add file to include what will be committed. So let's do git add mars.txt and then enter. All right, and you might get a warning message like this about the line ending, but we don't have to worry about that just now. And so we did git add mars.txt, and then let's do git status again. And now it says on branch main, no commits yet. So no, even though we did git add, we didn't take it as a snapshot. But what changed is that it now says changes to be committed, new file, mars.txt. So what's happening is that we're putting Mars into what we can call the staging area. And if we think of it in terms of taking a picture, when we're doing git add, we're asking someone to go stand in the place where we're going to take the picture. So git add would be equivalent to go over there, I want to take a picture, please. But we haven't taken the picture yet. So right now we're lining up people to get their picture taken, and the picture is going to be the commit. So let's actually go ahead and take that picture. And that is with the git command git commit. And then I'm going to use another flag here, -m, and then in quotes, say start notes on Mars as a base, end quote. What the -m here means is that we want to record a message to our future selves or people we're working with that's saying what the change we made was. And so with this command, the git commit command is going to take a picture of everyone we lined up with git add and then give it a caption, which is start notes on Mars as a base. So now it said a bunch of stuff. It might be a bit different for your computer. It says we're on branch main. It's giving a series of 7 alphanumeric characters, which is going to be the identifier for the commit. And then it gives us the commit message, our notes to our future selves on what change it was we made. And so we changed one file and inserted one line. And then I can't actually remember what this means, but some of the things in here are for not so much for humans to read, but if you're writing a computer program that or a script that uses Git, sometimes it'll read things in here like that. So, okay. So we just took a picture of the state of the repository after we added this new file. So let's do git status again. And it's now saying on branch main, nothing to commit. So we just took a picture, so there aren't any changes from that picture. And then working tree clean, which is also related to us not having made any changes. Now now that we've made a commit, now that we've taken a picture, we want to look back on the picture or pictures that we've taken. And we can do that with git log. And what git log will do is print out information on every picture, every commit that we've made in the repository for this branch. And it's giving a really long identifier, and usually it's fine to just use the first 7 or so characters. It's saying the author and then giving the time. And it has the message, which is start notes on Mars as a base. Right. So now let's add some more information to the file. For this, let's do nano again, or your favorite text editor. And then mars.txt. So we're opening mars.txt again. And then the 2 moons may be a problem for Wolfman. All right. And now that we typed a second line, again, it can be something different for you. I'm going to press Control X again, and then Y to save the modified buffer, and then enter the file name to write. So Control X, Y, and then enter if you're using nano. All right, let's do git status again. And now after doing git status, it says we're on branch main. And now there are changes not staged for commit. And so it says we modified mars.txt. And it gives a help command that we want to use git add or a different command. This git add is usually the better one to use. So, so now that we made this change, but didn't use git add, it's like we didn't tell someone to go stand in the place where we're going to take a picture. So if we take a picture now, it's not going to record the changes that we made in mars.txt. And so let's do git add again. Oh, wait, let's try something else. And apologies if you hear a baby crying outside my window. Let's see. So let's do git diff first and press enter. So git diff. And the important things here are at the end. And so the plus sign indicates the change that we're making to this file. So this is like the difference between the picture, the snapshot that we just took, and the current state of the repository. And if we deleted a line, there would be a minus sign here. And so it's comparing mars.txt old and new. And the rest of this is mostly machine readable stuff that we don't need to worry about. Okay. So now let's do git status again. We didn't need to do that since I just did it, but doing git status helps us make sure where that we know the state of the repository before we take one of these snapshots. And so let's do git add. Let's try doing this without git add. So let's do git commit -m and then in quotes add concerns about effects of moons on Wolfman. And so we did this, it says that there were no changes added to commit and to use git add or git commit -a. So we tried to take a snapshot, but we didn't use git add first. So we didn't tell Git to record the changes that we made to mars.txt. So now let's do git add mars.txt. And now we can do the same commit message. And for a shortcut, I'm going to press up twice to get the same command that I used before. And you can alternatively copy and paste from above. So it's a shortcut on Unix terminals that you can press up to get previous lines. And so now we did git add, and if we do git commit, now it will have, it says that branch main, a different identifier, and the message that we just put in, and that we changed one file, and we inserted one line. So now let's try this again. Nano mars.txt. And let's add one more line at the end, but the mummy will appreciate the lack of humidity. And then Control X, Y, and enter. All right. Now let's do git add mars.txt. And let's try git diff. And when we do git diff, now it's not printing anything out because it's git diff will only print out the changes that are not, that we didn't already tell Git about with git add. So let's do git diff -- staged. And the staged means that we want to include the changes that we made, but we already did git add for, so that we already put into the staging area. We already lined them up to take a picture of them. And so we want to record this again. So let's do git commit -m again, and then discuss concerns about Mars's climate for mummy. And so we took another snapshot. We recorded what happened. So let's do git status again. And now it says on branch main, nothing to commit, working tree clean. And let's do git log again. And then we have the different commits that we already made, the different snapshots that we took. So this was the first one. This was the second one. And this was the third one. All right. So now I think it was a good time for a 10-minute break. So let's see. Yeah, feel free to stick around if you have questions, and otherwise feel free to stretch or get something to eat. So see you in about 10 minutes then.
Let's see. So here, part of the screen. All right. Generally, when you open up PyCharm, if you don't have something already going, they ask you if you want to create a new project. But I have one open. So here I go new project, and I'm going to create a new Python project. And in this case, if you're doing this, say, with Spider, you'd probably just create a folder on your desktop. So I'm just going to create cancel a new folder on the desktop called the hack demo. Okay. In PyCharm, I can select what interpreter right off the bat. And so generally it will recognize the base interpreters for your computer. And it can recognize any virtual environment you've already created. And you can create a new virtual environment all at the same time. Okay, so create new window. So now I basically just have an empty directory. That's basically all I have. And Git has not been activated yet. So in PyCharm, you go VS Code, and you just go enable version control, and you go enable Git. You go, okay. Now I have Git enabled. So now this directory is under Git version control. And as you saw in Nick's set, when he went through configuration, you ended up getting this .git file or directory. So this has all the settings and management Git will use for your project.
And I would like to reiterate that that's local, not remote.
Yeah. And unlike, I believe VS Code, okay, so PyCharm, Nick went through all those configuration settings for Git at the very beginning of his discussion, which basically populated this config file. Now, PyCharm itself does not have any settings to control this. So if you wanted to do all those things, you still have to use, and you're using PyCharm, you still have to use the command line to get those in. Okay. So I'm trying to think. I'm trying to think how you activate Git using the desktop. Well, let's see. Let's do a little exploring here. So
Eric, could you make the font size bigger?
Unfortunately, let's try this.
Control plus, probably, maybe.
No, unfortunately you can't control the font size of the menus in this. Does that help? That make it better? Okay. Okay, so let's do it a different way for Spider. Let's see what we can pull off here. So what I'm going to do is I'm going to go ahead, and I am just going to go to Nick. Were you going to say something? No.
Just leading stretching exercises.
So I'm going to go to my desktop and I'm going to create a Hack2 demo. So I'm just going to do a new folder. I'm going to call it a Hack2 demo. Okay, so I'm starting a whole new directory, a whole new project. There's nothing in it. All right, so on the Spider side of things, I'm going to navigate to that directory. So desktop, Hack2 demo, select folder. All right, so now I'm in that folder. And okay, so now let's go to GitHub desktop. So if I have a GitHub desktop, so this would be the GUI interface for those Spider users. I need to add a new repository to this. So I'm going to go add a new repository. And I'm going to choose a path. So I'm going to go to my desktop. And I'm going to choose Hack2. And I'm just going to name this the Hack demo. Okay. And I'm not going to put a git ignore in yet, nor a license. I'm not going to initialize it with a README. And I go create repository. All righty. So that didn't work exactly as intended. Because that ended up creating a hack directory within the Hack2 demo. It's not exactly what I wanted.
Yeah, it doesn't run a git init. So if you had created a folder and from the command line navigated into that folder, you could type git init and it would initialize it the way you were trying to do it.
Yeah, I'm trying to pull this off with just doing doing it through the command line. And my approach, this is not my workflow, so I'm kind of learning it as I go. Let's try add local, choose the path. Let's go. Yeah, select folder. This directory does not appear. Delete.
Create. Would you like to create repository here?
Yes. So create repository. We're going to call this the Hack2 demo. Create repository. All right. Refresh. Hack2 demo, and that was successful. So now, if you did it that way, now if you go back, you can see in here we now have a .git. So that's how using Spider, since Spider doesn't have built-in Git, you can use Spider in combination with GitHub Desktop to bring that directory under version control. Okay. So variable files. All right, so now we can see those under here. Okay. Okay, back to PyCharm. All right, how are people feeling? Is this people doing all right with this? Do you have any questions so far? All right. Okay, so now that I have a repo, don't have the config. So the config, you don't have the config. Are you talking about this one here? You just have a do you see the .git?
.git is a hidden folder, so you might have to change that to see the .git folder, by the way.
Yeah, that's why I was asking the question. If you're on a Windows system, as for me suggested, it's a hidden folder, so you'll have to go to the View tab and check hidden items, and then you should be able to see any dot whatever folders. Okay. All righty. So now we don't want, so right now PyCharm thinks that .git should be under version control, and we don't want that. We also have for why is this doing this? Cancel. So we go back to the hack demo one. So when you create a repo with PyCharm, you also get this .idea. This .idea is a configuration directory for PyCharm. This is something we don't want under version control. So of course it does that. So the first thing we want to do, so you can see if we go to this Git tab, we have all these files that PyCharm thinks to add to Git, to commit to the version control, but we don't want these because these are all configuration settings for PyCharm, which is something you don't want to keep under version control. And so what you do, you can add a new file that's called a .gitignore, and this is just a list of patterns, file names, or patterns of files or directories that you don't want to have under version control within this directory. So we don't want a .git under version control, and we don't want a .idea under version control. Okay, and so now what will happen, so I've made this file and I've added this, and I want to commit this to my default branch, so all those other things are no longer under version control. So I go git commit, okay, and now all of a sudden you've seen all those files that PyCharm originally wanted to add to version control are no longer in this dialog. It's because I've listed as being ignored. So I'm going to add a commit message of add git ignore. Okay, commit. So now I've established my first commit. And so you can also see our default branch here. So down in this bottom corner, we have a quick view to all of our branches. So our default branch currently is named master. So I'm going to go ahead and just rename this back to main. Rename. Okay, so now my default branch is called name. If I was doing this in VS Code, so I go to VS Code. So I want to add a file, new file. I'm going to save that file in hack demo. I'm going to save it as a .git ignore. Save. All right. No, that's not what I wanted. Let's try this again. That's not how I wanted. Delete that. Yes. Why are you doing that? All right.
Oh, Eric, there are a few questions in the chat about,
Yes.
I think a few people are lost.
Yeah, okay.
Yeah, it looks like people lost when we started going to the IDE.
Mhm.
It looks like people started getting lost. So there are two things. It looks like one is people are doing different things on different IDEs, so that they're not following very well. And two, it might be going too fast. I do notice that the pace is pretty quick.
Okay. Do okay, I can slow down. I'm thinking it might help that I stick to a single IDE then.
That would definitely help. But like, for instance, one of the questions in there was, how do I do the same thing with VS Code?
Yeah.
And the, you know, I don't know.
That's like the thing is, to answer that question, you need to know a few things. For example, if first thing is that the whole IDE thing which you were adding, Eric, is not kind of like relevant to VS Code, because for them it's a different thing. It's .VS Code which forms. So
Yes.
so if you're not
Okay,
aware of
so
that, that can get tricky.
Yeah, but
Okay.
even before that, Ramiz, I think the first one that let's start. I think it's a good way to start. Let's go back to Arian's question.
Mm-hmm.
First, he said, "Is it being recorded?" But he
Yes.
said he doesn't even know how to create a repository using VS Code. So it looks like you went through the steps to create a repository in PyCharm, and you created a repository in Git desktop.
Right.
Which
yeah.
actually, to your question, Arian, Git desktop, that the repository that was created with Git desktop is now visible to VS Code.
Mhm.
So those steps that we used in Git desktop, once you have that, you can go to File and then navigate to that folder that you created, and you could actually begin working on that repository. And Visual Studio will recognize it. The nice thing about Visual Studio is it picks up, if it looks basically for that .git file, and if it finds that .git file in a folder, it automatically starts managing for that.
Ramiz,
Yeah.
you're following along right now?
Pretty much, yes.
Can you share your screen and do basically what I did through adding the .git ignore?
Yes, I guess. I'm just wondering what. Okay, yeah, sure.
Okay, let's give that a shot.
Right. Let's see. Right. So so this is the GitHub desktop, and it was basically going here and let's see, new repository, and so this is my local path. That's where all my Git stuff is, and I would just say hack demo2, and then git ignore. I would just since this is going to be a Python thing, I would scroll down and go to Python. Where is it? Python. So this will automatically add a git ignore file, which is what Eric was doing. And if you want, you can initialize it with a README, but don't have to. License, we just ignore for the time being. And then you press on create repository. So it will take a few seconds. And while it is doing that, I can open a new window for my on VS Code. And by Control K and O is the shortcut to open any folder. And I can go to that folder. I see the hack demo 2, and oops, hold on. Let me get rid of this. And I open that in VS Code. And now that is visible here. So in the VS Code, that's the folder I'm seeing. Desktop, Git, hack demo 2. There are the Git attributes, and there's the Git ignore. So because the Git ignore, I populated it with the Python version, you will have a lot of things which is related to Python, which gets ignored. What that means is if you are pushing stuff to your GitHub repository, none of these kind of files will get pushed. Okay, so any file which has well, better example would be anything which has .env as the extension name won't get pushed to GitHub. And Git attribute is it's just there for the time being, which is what Eric was talking about. So we have reached so far. Does this make sense to people, or especially Ariane and whoever is working with VS Code, right? So the difference was we started with creating the file on GitHub desktop, create a normal repository, and then you open the VS Code by pressing Control K and O. You navigate to that folder and open it in GitHub, open it in VS Code, and you will see these two files. By default, since I'm using Linux, by default, all these dot files are visible. But if you are in Windows, you might have to check the option of make the hidden files visible to do that. So also, if someone is like still having problem with this, I think in like in a few minutes we will have a break, and we can go over this again during the break by breakout room, so that different people can do with different IDEs. And with that, I will stop sharing.
My slides?
Looks good.
Great. All right. So going to give a quick talk on Zripple, which is this X-ray radiographic image processing library that I put together during my postdoc here at Los Alamos. And I put this together to sort of solve this general problem that we have within plasma physics and the high energy density community, which is we have these nice radiographs, and you know, we then want to identify features within these radiographs. So here I have a shock traveling down this tube, and it interacts with this bubble, and I want to, you know, separate out these features from the background and identify where are the edges of these features. And you know, typically we do sort of these 1D lineouts, or you might go in by hand and even click and, you know, choose points where you think the boundaries of these are at. But they're a nice set of computer vision libraries like scikit-image out on the web, which can actually do this for us without all this human-induced bias and without the noise problems of, you know, doing 1D lineouts. So I put together sort of a pipeline that cleans up these radiographic images using various median and morphological filters, uses watershed segmentation. You can extract these contours out. Through contour here that you can see, which picks up shock front, and an orange contour which picks out the bubble. And so we can reduce bias from human input and increase reproducibility. And I put two links in the chat which have a DOI to the paper which describes the techniques here, as well as the source code for Zripple is up on GitHub as well. Just digging into sort of the features of what's going on underneath the hood, you know, we have this input image. We take the gradients within that image, and you can see the gradients do a pretty good job of pulling out, you know, where the bubble sort of is, where the shock is, but there are lots of gaps. So and just pull out gradients, you wouldn't get the full contours. So what watershed segmentation then does is we initiate markers in regions where there are low gradients. Underneath the shock, all this orange stuff is one continuous marker region. Ahead of the shock, this pink is marker region. And so the watershed segmentation then treats the image as a topographical map, where regions that are bright are high altitude, regions that are dark are low altitude, and it starts filling it up based off of these markers. So you can imagine this being orange water that's pulling upwards to higher altitude, pink water, it's going upwards to higher altitude, and where these two bodies meet, there'll be a dam, and that's going to identify the feature contour. Right-hand side, we have the fully segmented image, and you can segmented out the shock front. So you can then apply this technique to multiple radiographs, and you get these nice 2D contours where you can track shocks and bubbles and other features over time. So that's Ripple, the library. And so if you want to know some more details, take a look at the paper. The code is up on GitHub, and I'm currently working on putting together some examples and documentation so that it's a bit easier to dive into it.
Oh, that was lightning. Okay, thanks, Pablo. Are there any questions? Just as a note, we'll have more of these open source software related presentations tomorrow. We'll have to be mindful that we give them enough time.
I have a question. And Pablo, you're part of the committee. How did you see that integrating with the mission of Plasma Pi? But by the way, great talk. And I love the speed. That was perfect.
It says lightning on the tin, right? Yeah, I mean, I guess it follows the general mission of, we want to get useful tools in the hands of people. So with Zripple specifically, even though Scikit Image has all these nice tools, you got to figure out how to put them together yourself. So it doesn't really have a convenient way to do watershed segmentation using gradient-based markers. There's like an example hidden somewhere in the documentation, but it's not really easy to use. So this is really trying to package it together in a way where you only, use 3 input parameters, you play around with them, and then you can pull out these contours. So I think that aspect of it is in line with Plasma Pi, and also open sourcing these codes so that you can then interrogate them and add your own features as needed.
Yeah, I think this points at a strength of the open source software development is, this kind of image processing is not something that, is so unique to just you. It's very, it's a very common problem, yet everyone doesn't need to go through what you did to make the solution to this. So part of open source software ideology is to prevent people from duplicating code and effort, and rather just use what's also in the community to get to the core science and save everyone time. So thanks for developing this.
The question I was thinking about, or what it motivates, we use AstroPi units within Plasma Pi, and we've created particle. We try to leverage best practices from any open source contributions we can. And I was wondering, is this something like, what would this be something that we could incorporate into, and what would incorporation look like? Or does it depend on the application, and you just use, this is just to get to know other resources that are available?
So this piece of code is pretty general. Like I've used it on radiographs from various platforms that we've shot on the Omega laser facility, as well as some radiographs from NIF. So I think it could be general enough to go into Plasma Pi if that is something that people are interested in. So that's something we should discuss. I know we've certainly discussed some other codes that I've released as far as putting them into Plasma Pi. There's some filtered diode unfolders, in general, that we could possibly include.
I think that would be great. I think the I think the biggest hurdle or issue that I want to make sure that gets addressed if you contribute to Plasma Pi is getting proper credit. That's the thing. I want the original creator to be able to get credit for their own work, be able to cite the original papers associated with it. But yeah, we should talk. I have several ideas in how to incorporate other third-party packages into Plasma Pi. So I think it would be a good discussion for us to have after the Hack Week.
Yeah, sounds great.
Okay, well, I hope people are, feeling free now to get lunch or dinner or wherever it is appropriate for them, and or just to get up, stretch their legs. So we'll be back in about 52 minutes.
Them one by one. I'll start with PyCharm, and then I'll go to the Spider / GitHub desktop, and then I'll hand it off so Ramiz can do VS Code. I just think that's going to be easier to follow. So to get yourself started, I have cleared out everything, all the file stuff that I created in the previous session. So now what I'm going to do is on my desktop, I'm going to create a new folder called Hack Demos. So I'm going to basically make a new repo for every single IDE that I'll be using, and I'll put them all here so you can follow along in the same pattern. Okay. All right. So with PyCharm, what you do, it uses the terminology of projects. This will be the same thing as your repos. So if you want to start new, you go File, New Project. And so in this case, I want to create a new Python project. I'm going to want to create this in the, sometimes this is slow. On my desktop, I'm going to put it in, oops, wrong. Oh, that's the right spot. Hack Demos. I'm going to put it in the Hack Demos. Okay. Okay. I'm going to name this one Hack PyCharm. So I'm creating a new repo called Hack PyCharm. And as I stated before, you can select what is going to be your base interpreter here, your Python interpreter. It will generally recognize whatever Python you currently have installed or any previous virtual environments you may have created. So in this case, you feel free, you can select any Python version you have right now. It's not going to matter. So I'm just going to go with Python 3.9. You also have the ability to create a virtual environment at the same time you're creating the project. All right, so I hit create. I'm going to open it up in the current window. So now I've created a new repo called Hack PyCharm. As of right now, it's not under Git control. Okay, so in Git to get it under Git control, I go up to VCS, and I go enable version control. So I hit enable version control, and I have a drop-down menu of all the version control systems I can choose from. So I'm going to stick with Git, and I go okay. So now this new repo I made is under version control using Git. So if you were to go look in your file explorer, so now we're in the Hack Demos. I created that Hack PyCharm repo. And if you look in there, I have hidden files on. You'll see a .git in here, and you'll see a .idea in here. This .git is basically the configuration. This is the directory that Git uses to manage all the stuff it's going to do. The .idea here is the settings directory for PyCharm. Okay. And Ramiz and everyone else, if there's any questions, can you that pop up, can you please direct them towards me so I can pause appropriately? Okay, so if we look in our project side here, we have the .git here. Currently, we don't see the .idea, but if we go project files, we should see, no, it doesn't. Of course, it doesn't. One of the tabs that you will use the most often in PyCharm is the Git tab here. Git tab, under local changes, it will show you everything that is new that hasn't been committed to Git yet. So in this case, it's telling me I have all these files that are in red. They exist in the directory, but they've never been committed to Git yet. Now, these files I don't want committed to Git. They are settings for my session of PyCharm. So when you're doing collaborative work, you don't want to share this with everyone else you're working with, because they're going to have their own settings. So you want to tell Git to ignore these files, and to do that, you create something that's called the .git ignore. So you go file new, file .git ignore. Okay. And now it's asking me if I want to add it to version control. Like, yes, I do want to add this to version control. And in here, this file contains file names that you want to ignore, or file patterns that you want to ignore. So in this case, I'm going to want to ignore the .git, and I'm going to want to ignore the .idea, because I don't want either of those under version control. And so, okay, so I added those. So now if we go look down here in the version control, I still have all these files. It's just saying that they're not committed yet, but it's also showing that I've added this .git ignore, and I have these new changes. So everything here has been staged, but it hasn't been committed yet. So what I want to do is I go git commit, okay, and it pops up with a dialog box to commit my changes. Now, since it automatically saw this ignore, I was like, okay, and it removed those unchanged track files. It's like, oh, it read the ignore and knows not to handle them anymore. So I'm going to add a commit message, add.git ignore, and commit. So now that's committed. And we got no new changes under here. And now anything that changes in the .idea, you can see now it's grayed out. Git's not going to try and track it anymore. All right. As we've stated earlier, the default branch name historically has been master, and there's been a shift to call that main. PyCharm still likes when you create a new repository to have your default branch named master. So I'm going to go ahead right now and go ahead and rename this. So if you click down here in the lower right hand corner, it'll pop up with all the available branches that you have. And so I can go master, rename, and I'm just going to rename it to main, rename. So now it's been changed to main. Okay. So now what I'm going to do, I have an idea on some code I want to introduce. So I'm going to go ahead, instead of adding the code directly to the main branch, I'm going to make a new branch. So I'm going to go back to this little tab down here. I'm going to go to main. I want to make a branch from main. So I click on main and I go new branch from main. And I'm going to call this one say hello. Okay. I'm going to create that. So now I'm working on a different branch. And so if I go to my log, you can see I have two different branches. Right now on main, I have that one commit that I made earlier called add.gitignore. And if I go to say hello, it still has that one because I copied this branch from main. Okay. So in here, I'm going to add a new Python file, new.
Eric?
Yeah.
I could be wrong,
Mhm.
but I don't think we've really covered branches to a degree that just saying you created a branch makes sense to people. I know you showed the versioning and stuff, but I think it might be a good idea.
Pop up the diagram again.
Yeah, and just reiterate, what does it mean to create a branch? Why would you create a branch? Kind of motivate that.
Okay, give me a second. Go back. So earlier when I was showing my summary slides, I had this little cartoon going on here. And so what I was just doing is when I created the repository, I had just this main branch. I just had this single line of work and I made my first commit. So basically in the workflow we just did, I made my first commit and we're sitting right here between these two commits. Basically, we're sitting right here. Now I have an idea of some kind of code that I want to introduce, but it's generally good practice not to do work on your default branch, on your main branch, because you can run into a lot of collisions with different work. So you kind of want to keep that branch as clean as possible. You're only going to want to merge in code that's basically finalized. Okay, so if you have an idea of something you want to work on, you break it out into new branch. And that's essentially what I did, is I went ahead and I created a new branch. And in this case, I didn't call it idea A. I called it, I'm going to call it say hello. Okay. And then I'm going to work on that. I'm going to make a couple commits to that, and then I'll bring it back into the main branch. So this allows me to work on independent ideas. And usually you don't finish developing an idea in an hour. It can take days, it can take months, it can take a long time to develop an idea. That's a big reason why you don't do it on main, because if you do it on main and you have a second idea, where do you start? Your main branch is now kind of, in quotes, corrupted because you're working on an idea. You want to keep main clean because I can now create a new branch from main and start working on a completely different idea in parallel with my first one.
And if you'd allow me to chime in there.
Yeah.
One of the things that may not be clear is, why would you want to keep main clean? And the reason why you would want to keep main clean is because you have code that actually does something. So you have code that runs an analysis that your team, you yourself, or your team wants to continue using while you develop your idea on the side.
Mm-hmm.
So you know the motivation is that if you have code that is productionized, or even it doesn't even have, it could be a development code, but it's one that produces results. You don't want to necessarily have that one as dynamic as some side idea that you're working on. You need to, you need to publish a paper, and you need an analysis, and you need that analysis done today on working code, not on your idea branch.
As kind of another example, for Plasma Pi, we have the main branch, and that's the one that goes into releases, and we have a user base for that. So we don't want to pollute the main branch with partial code, because now we're affecting all of our users. Especially if a user uses some functionality in our branch that's not quite right yet, hasn't been fully tested. I don't want them to use it to analyze their code and write a paper based on it. So it can have big implications. So so for us, we try to keep it as clean as possible. So all the code that goes into it that's released is tested. And so we have a degree of confidence on how good it is. Okay. Any questions? All right. Thank you, Will. Okay, so I'm going to go back to PyCharm. Oh, so I did already create the say hello branch. So again, what I did is I went main. Let me bring this back up here. I went main, and I went new branch from main, typed in the branch name I wanted, and then it created the branch for me. Okay, So now in this case, I'm going to create a Python file, new Python file. I'm going to call this hello.py. Okay, so I created a new one, and now it's asking me to add it to Git, and I do want to add it to Git. So I'm adding it to Git. So now I have this blank Python file, and I'm going to just define, a function that says say hello. Okay, it takes some input argument. Let's call it name. Okay, and all it's going to do is print to screen hi name. Okay, so if you're not familiar with this, this little fancy tidbit you see here is called an F string. It's a, I can't remember if it was introduced in Python 3.6 or 3.7. It's
3.6.
3.6. Okay, it's a very clean way of injecting variables into your strings, opposed to having to use the old format syntax. Okay. So I'm going to have this define this function that says hello. Okay. Okay. There's a question in the chat. F string. Oh, nope. Comment in the chat. Yes. F strings are absolutely fantastic. But what I specifically like about F strings is it considerably makes your code more readable. You see this string and you know exactly what's going on, opposed to an old style where you have to have a dot format or a pound sign to inject, and it's rather convoluted to follow. All right, so now if I go back to Git and I look at my local changes, I see that I have staged, I created the hello py, and I have a say hello function. So I'm going to commit this. So again, you can go git commit, or you can do a keyboard shortcut Control K. So you do Control K, your commit dialog shows up, and I go, I define a function, say hello, and I'm going to commit that. So now I want to run this script and see what happens. So I open up, not Python terminal, not Python console. So I'm going to open up my terminal. Oops. That's what I think this will still work. So now what I'm gonna do is I want to run this. So I'm gonna go Python minus M. Yes.
Sorry, there's a question. There's a problem in chat from comment.
I don't see changes tab in my Git panel. So if you come down here, you don't see this local changes, or there's nothing in there.
Yeah, that's it. I have the log and the console, but I don't have local changes.
So if you look on any of these other sidebars, do you see a Git in there? You're looking for this little tab that says Git.
Yeah, I'm there. I'm in it. And I have log, head, and console, but I don't have local changes.
You don't have local changes. So if you look up in this top bar, do you see something that says VCS, or do you see Git?
I see Git.
You see Git. Okay, so you are under Git.
I have branch and everything, so I can follow everything. I just don't have this little tab.
Have you created the hello?
Yeah.
The hello.py file?
Yep.
You have. And you've put stuff in it.
Yep.
And you don't see this local changes at all.
Exactly. I just see log and console.
Why don't we let him share his screen again? He had the ability.
Yeah,
that might be interesting.
Yeah, that one I'm puzzled by. So yeah, I'm going to stop sharing for a second. Let me enable share screen for you. Okay, you should be able to share now.
Yep. Right, so can you see it?
I can see it. Yes, I can.
Yeah, I just oh, messed up.
That is a bit puzzling. I'm curious why.
Oh,
Let's
I'm
see
Is
what
it
happens.
possible that that's the Linux version?
Right.
No, I don't think so. What happens if you just press Control K? or Command K, depending on what system. Are you on Linux, Mac, or Windows?
Linux.
Linux. Okay. Go to your Git dropdown.
I just press Control K and I see this thing. It's kind of what I wanted to see, isn't it?
Oh, yeah. Okay. So this is what you want. So you can still commit. So I'm curious if you go ahead and commit this, if you'll finally get a changes tab.
Hold on, he's got the window, the dialogue maximized for the whole screen, and that might be preventing us from seeing.
Yeah, sorry, I messed up the view then.
Yeah.
Pavel put in an issue that was put up on JetBrains that discusses this specific issue. Thank you, Pavel. Local changes in shelf have been moved to a separate commit tool window. Okay. So the old behavior. So let's see here. If I go settings, non-modal commit. Okay, so go to
Hold on one second before you go to Clement. When you were moving the dialogue, move it all the way down to the bottom.
How do you do that?
Well, you were click on the bar.
This one? Which
No, yeah, to the right of it. Yeah, exactly. Now go down till you see it move across the bottom all the way.
all the way?
Yeah, so right now you moved it parallel. You see the tab over on the left side there.
Sorry, I'm confused with what you're saying.
So
Yeah, click on that.
Right, this?
Yep.
Yep.
Okay, now move the tab to the right, not there. Keep going, further. There.
Yeah.
Oh, now it moved it to the right.
no, what
There's
I do.
there's a place in there where it will move it back to where it was originally.
Okay,
Yeah,
so
don't worry about that. It's just a view problem. I'll figure it out.
click on the Git tab.
This thing?
In the bottom right corner.
Or yeah. All right, because it's not
Yes, sir.
sharing my screen, because it's not for some reason it's popping out when I click on it, so you don't see it, but I do.
Okay, so go up to file, and I'm assuming it's settings. Go to file settings.
Right, file settings.
Yeah, and do a search for non-modal, non-modal. All right, and go down to commit and uncheck that box.
Right.
Click apply and click OK.
Oh, okay, here it is. Thanks.
There you go. Thank you, Pavel, for posting that. All right, awesome. All right, all right, share. All right. So now we have the say hello function, and I'm going to go ahead and run this in terminal. So hello.py. Okay. Arrow while finding module hello pi module not found. Okay, so that's Python m hello.py. Oh.
Python 3, right?
Yeah, I think there's something wrong with the interpreters right now.
Ooh, that's weird. Try it without -m.
No, it should work with -m. For some reason, unlike normal, it's not appending the Python path, so I can't find it at the moment.
Oh.
That's what's happening. I think they changed something up on me. error while finding module. All right, so we'll do this a different way. So go into your terminal instead of using the built-in one. So open up a terminal. Okay, it can be PowerShell, or it can be or it can be some Unix space, a bash shell or something like that, and just navigate to your repo. So desktop, I got hack demos, and I'm doing the hack PyCharm right now. ls. So this is where we're at. So now Python 3 is what you want to use. So I have version. All right. Oh, that's why. If you're in Windows, you have to use a Python -3.9. Okay, -m hello.py. Okay. Oh, well, I'm a little dense. The file name is say hello. And wait, no. Oh. Just type in say hello. I apologize. So you get, so on Windows side, you do pi -3.9 -m hello. If you're on a Unix platform, you just do Python 3 -m hello. Okay, and nothing happens in this case because all I have here is a defined function. I don't have anything to execute. I'm just defining a function. So I'm going to do some fancy magic, and you can do this if clause. If name equals main. So this is basically that this named under defines spaces. And so by setting this to main, that main usually gets attributed to this when you're running it from a console. Okay, so this is basically going, if this is being run from a console, do what's in here. So now what I'm going to do is I'm going to say hello, and I'm going to say awesome people of the hack week. Okay. All right, enter. You can see here I'm getting a little linter here. I'm getting these little squiggle lines. I know this one is because it's expecting there to be 2 spaces between functions. Okay, so I added that, that went away. And if I go back to my Git dialog, I have a change here. Okay, so I'm going to go Control K again to commit the change. I'm going to go add an if name. Okay, so I write a little commit message. This would be very similar to when you saw Nick go git commit -m and then type out that message. This is basically the same thing you're doing. So I go commit. So now that exists. So if I go back to my terminal and I try to re-execute my previous command. So again, for those on Unix side, you do Python 3 -m hello. I'm going to do pi -3.9 because I'm using a Windows terminal. Now it says, hello, awesome people of the hack week. Okay. And so.
Just a question. Would that work still in your terminal now that you realize that that's the pi dash, because you're using a separate terminal?
Oh, yeah. So if I go back to here, yes, it should still work. Python -m say hello. Hello, awesome people.
I just don't want anybody being scared because of the confusion earlier.
So in fact, if I go back to my original environment, it was just the base Python 3.9. I'm going to close this out. I'm going to start a new terminal. Okay, so I'm in PowerShell right now. So now I would have to do pi -3.9 -m hello. Hi, awesome people of the hack week.
Perfect.
Okay. Now, if you noticed, when I was using this virtual environment, my Pi 39 Plasma Pi, okay, So I'm going to close this up. I'm going to relaunch the terminal. Now this I'm still in PowerShell, but this one is now using that virtual environment. In this case, I can get away with Python -m hello, because in this virtual environment, when I created the virtual environment, this Python alias was created. So this Python is still pointing to version 3.9. So that's why I don't, even though I'm on a Windows terminal, I don't have to use that pi -3.9, is because I'm in the virtual environment and this alias was created. Okay. Now, one of the really nice things about writing your code like this is I've created this function. I might want to use it in other places. And so this function, I'm going to open a Python console here, take away my variables. Now this function is now importable. So I can go from hello, import, say hello. And you saw I got quick completion here because I'm hitting tab and PyCharm has already inspected the file and it knows that's the only thing in the file that starts with an S. So when I hit tab, it auto completes it for me. So I do that. And now it's imported this say hello function. So I can go say hello. And I will say hello to Will. Hi, Will. Okay. So this kind of allows you to take that step from having a script-centric way of coding versus a package-centric way of coding. Now you can write a lot of common tools as functions that can still be imported into other scripts, or you can have this if.main and you put your unique stuff down here so you don't have to touch all the original tools above.
Yeah, we got a question. What is the -m command line for? Clement gets the same result without it.
The -m is an indication to Python to run the following thing as a module. So it knows you're trying to execute a module. I can't say details on -m versus not using it. It's generally safe practice just to use the -m. And I believe if you do, if I go to back to the console, if I do Python, I think it's -c print pi. This knows to run what's following after the -c as code. So this is a way you can execute inline code while you're in your terminal.
Okay, what's a bit confusing is actually when I put the -m, it doesn't work. And when I don't put it, the code runs without any problem.
Have you added the dunder underscore name equals main, Clement?
Yeah.
Because what happens is that
Ah.
dunder catches when you run in module mode. That is what catches the scenario where you don't have where you're running in module mode. So that's why module mode works instead of the -c option. If you didn't, the -c option should, if you try the -c with, if you haven't made the change yet, try the -c. Yeah.
Okay.
Thank you, Nick. Nick pointed out that the dunder, when we use the word dunder, and it's a very deep concept, or I guess it's a deep rabbit hole, but the double underscore name double underscore and the double underscore main double underscore, anytime you see the double underscore, that's referred to as dunder.
Okay. Alrighty, so what I'm going to do now is I'm going to switch back to the main branch. So I can go, I click down the bottom right corner and it comes up with my available branches. I'm going to go to main and I'm going to go check out. So I haven't lost anything on the previous branch. I have just switched back to main. So if I go back to my cartoon earlier, we go back to here, basically what happened is I had main, I broke out this branch, I made 2 commits, and I have not merged it in yet. And so I'm still sitting out here, I'm still dangling out here, but in my workflow, I have switched. So now I'm sitting down here on the main branch. This one still exists in parallel, but I'm actively working in the main branch opposed to my idea A or say hello branch. Okay. So now what I can do is if I go to the Git tab and I go to log, we can see these 2 branches going in parallel. So we can see here's the commit I did with the .git ignore. So that's where main is currently sitting, and say hello has 2 more commits ahead of it. So we know that say hello is ahead of main right now. That's the terminology that it uses. You can also go and do say, I'm on main right now, so I can say hello, and I can show, I can compare the 2. And this comes up with a very similar dialogue down here. There are no commits in main that don't exist in hello, and there are 2 commits in say hello that don't exist in main. Okay. So I'm going to purposely create what's called a merge conflict. So
Wait,
I'm going to
can you restate that? Because that's actually deep, and it goes back to your picture as well. Your picture shows that main can be moving and that your branch can be moving.
Mm-hmm.
But right now there's nothing in main that's changed, so that's actually empty.
Yeah, so this is empty because all the changes that are main are currently in say hello, but say hello has 2 changes that are not in main.
And can you go back to your picture, your graphic?
Yeah.
This illustration here shows a scenario where there might be changes in main while idea is being developed.
Yeah, so that's what I'm going to do right now. I'm going to make a change in main, and specifically, I'm going to make a change in main that touches the same kind of code as what is in the idea branch. So I'm going to purposely create what's called a merge conflict. So I'm going to touch the same place in 2 different branches. So when I bring them together, I have to do some kind of resolution because otherwise Git won't know how to merge them. Okay. So what I'm going to do, so I'm still sitting in main. So I'm going to purposely create a new file, a new Python file, and I'm going to call it hello.py. So I'm calling it the same file as I had done in say hello. So I'm already creating a merge conflict because I'm creating the same file 2 different times. But in this one, I'm just going to add its own string. So it's just a fancy comment for that file. And I'm going to say a module that defines the say hello function. Okay. And I'm getting the amber squigglies again because the Python standard is to keep a blank line at the end of your file. Okay.
Also fix module.
Oh, thank you.
Okay.
Not module. Okay. All right, I think we're good. So now I'm going to commit this. So again, I'm going to go Control K. You can still go up Git commit. I'm going to do Control K to get the commit message. I'm going to say initialize the hello.py. Okay, and I'm going to commit this. So now you can see in this Git log, it's changed. main is now a step ahead of hello, say hello, but say hello has 2 commits, these 2 dots that aren't in main, and main has 1 commit that's not in say hello. So if I do the other way, where I went say hello, compare with main, I get this dialog back. And so this main section now, as before it was empty, but now we have one, it's telling us we have 1 commit that's in main that's not in say hello. And we have 2 commits in say hello that are not in main. So now in our little cartoon, we essentially have 2 commits up here in the say hello branch, and we have 1 commit down here in the main branch. Okay. Now, the issue we have is we want to merge them together, but we purposely have what's called a merge conflict. So if I go back here, so I'm sitting in main, and I'm going to click on say hello, and I'm going to say merge say hello into main. So now I'm requesting to bring the changes from say hello into my main branch. So when I do that, I'll have a dialog that pops up here. I have this conflicts dialog, okay? And it's telling me there's some kind of conflict in say hello between the 2 branches, or in the hello.py between the 2 branches. So if I double click on this, it'll pop up with a window that compares the 2. So on main, I have this doc string that doesn't exist in what the final result's going to be. So on the left here, I have the main branch. In the middle here, I have the resolution. And on the right, I have the say hello branch. So I actually want both changes. So I'm going to accept, I'm going to do this little arrow. I'm going to accept it. Now, if I don't want to accept this, I can hit the X, but I do want it. So I'm going to bring that in as well. Okay, so now I have both, but it's not quite right. So I'm going to add an extra space in here, extra 2 space in here to get rid of the Pepe warning. And so now I have a resolution. These 2 had previously conflicted. I brought them together. I made some kind of changes to make sure that the result I'm going to have is what I like. And I go ahead and I click apply. Okay, so now if we look at this, so this is automatically updated. Say hello has no commits in it that are different than main, but main still has commits in it that aren't in say hello. Okay, so if we looked at again at the kind of the diagram down here, we were on main, so this kind of bluish color is main. We had made a commit here that was not in say hello. We made 2 commits in say hello that weren't in main, and we went ahead and we merged this in, and we merged this in with what's called a merge commit. Okay, so we made the resolution, and then Git made a new commit that's referred to as a merge commit that indicates that these 2 have been put together. Okay, so now we have functionality from say hello into main. So like I said, we're still sitting in main, and now we have to say hello.
This might be a good opportunity, Eric, to pause and see where people are at. Because that was pretty heavy.
Yeah. So this is perfect. This is actually the stopping point for me for the Git demo before I move on to doing the same thing in Spider. So I absolutely agree with you, Will. I will pause here, and I'll take any questions that are related to PyCharm or any of the semantics related to Git. How are people doing? Any questions out there?
Maybe you can take a survey.
Doing Git in the terminal and had a merge conflict, what would the output be? I can't remember. Nick, you didn't do a merge conflict in your command line demo?
No. So usually there's a message saying that there is a merge conflict and that we have to go to each file and, like, let's say which files have conflicts, and then we have to go in and edit them manually and then do git add. So
What we could do, rather than trying to recreate Ricky's problem, we could go through and look at share his screen and do the same thing we did with Clement and
Yeah.
command line fix it.
If Ricky's up for that. All right, so he's
okay, yeah, the way to edit the
It-
files themselves is pretty similar between PyCharm and using a regular text editor. So
I would throw in there, conceptually it's the same, but the semantics are different. And so conceptually it's exactly the same as far as the workflow, but the actual implementation would be different. And so that was the reason, Ricky, we brought that up as far as looking at your session, because to describe it in principle is a little bit harder to understand than to actually show an example. So I think the best answer for that is it can be done through the command line, and I do it regularly, actually. But it's not something that, without an example, I don't know that it's a good idea to go through.
all right. Are there any other questions?
Pavel brought up a tool called Melt. I've never used it. I don't know what it's about.
To answer Ricky's question, I predominantly work in the IDE, but I still do some command line things. There's some things I just prefer to do on the command line. And so I think everyone does have a hybrid approach of some sort, but the degree on how frequently one uses one tool in that hybrid approach is unique depending on each person.
I'll tell you, if I have just one file that I made an edit to, and then I want to push it back to, commit it to Git, I'll almost always just do it through command line. Why open an IDE and all that overhead of opening IDE when I can just bang out a couple of instructions on a command line and be done with it.
the command line also works really well if you have complicated Git stuff to do. Usually there's more help online for the complicated stuff situations for the command line than for a particular IDE.
Yeah, I put it this way. I think the GUI IDE is basically a wrapper on Git. And like with every single wrapper out there, it doesn't encompass the full functionality of what it's wrapping. So there's always some things that it doesn't cover. For example, PyCharm doesn't, we'll discuss it a little later. We'll discuss this idea of remotes and you can connect it to your branches. PyCharm doesn't have that ability to change that up and play with those remotes. So I tend to go to a command line to do that.
Yeah, these are good questions.
Yeah, no problem. All right, so I'm going to go ahead and start doing it on the spider side. So I'm going to do basically the same thing, but on the spider side. All right, so I'm going to go back to my hack demos area, and I'm going to go ahead and I'm just going to add a new folder here. I go new folder. I'm going to call this the hack spider. Okay, so I'm going to do hack spider. Now, as we mentioned, Spider doesn't have built-in Git. So to get this under version control, I'm going to go ahead and I'm going to use I'm going to use GitHub Desktop. So I'm going to bring in GitHub Desktop here. Okay, so I'm going to bring in GitHub Desktop, and I'm going to go from this current repository. I'm going to go up to File, and I'm going to go Add Local Repository. Because I've already created the folder, I'm going to add a local repository opposed to creating a new repository. So I'm going to go ahead and I'm going to go Add, and I'm going to search out the hack spider. I'm going to select that folder. Okay, and it tells me that this directory is not under Git, so I'm going to go ahead and I'm going to put it under Git. Okay, hack spider. I'm going to keep the name as it is. Everything here looks good, so I'm going to go ahead and I'm going to create the repository. All right, so now in the GitHub Desktop, I have other repositories listed here, but the one that I'm going to work in is this hack spider. So I'm going to use GitHub Desktop solely for my Git interaction, and I'm going to use Spider solely for my coding. So I'm going to go, okay, now since that's directory is now under Git, if we go back to the directory, hack spider, could you explain the difference between create and add new repository? So I added a new repository because I had already made the folder. If I was starting completely from scratch and I wasn't and I didn't have a folder or a directory that already existed, I would have done create new, because then that would create the directory and put it underneath Git, because I already had the directory. Yeah, go ahead, Will.
Yeah, one of the things about Git, the architecture really hinges on whether it has a .git inside the folder.
Mm-hmm.
And so a folder that's under version control will have the .git, which you will never ever go into yourself. You will only have something that has management, either the command line management or an IDE. But if it has that .git folder in it and it is under version control, then the .git is what actually retains all the history of every change that you've made to this directory.
And so now, since I use GitHub Desktop to put it under version control, now that hack spider directory now has a .git in it. But you'll notice, because I did this with GitHub, I don't have a .idea in here anymore. However, I'm going to go ahead and where's spider? If I go spider, so let's bring spider back up here. If I go spider, I'm going to work in the spider directory. Okay. Now, let's say I know I'm going to be using that many people are going to be using this. So I'm still going to add a new file called .git ignore. Okay. So I'm still going to add that, and I'm still going to put in here .git, and I'm going to put it in .idea, because maybe someone that I'm collaborating with also uses PyCharm. And so I want to preemptively cover that. So if they make any changes, they won't accidentally commit that directory to the package. Okay, so I created that. So I did the editing here in Spider, and I'm going to bring back GitHub Desktop. So now on GitHub Desktop, it knows, okay, there's a new folder, a new file here, and someone had added the .git and the .idea to this. And so if you hit the history tab, here's the possible commit. Here's the file that was added. Here's the changes that were added. Okay. To commit this, I go head down here and I go added .git ignore. If I can spell git ignore, and I go commit to main. So now this add git ignore is sitting in main now. Okay. Okay, so like before, I'm going to go ahead and I'm going to create a new branch. So under this branch tab, I'm going to click down and I'm just going to type in say hello, and I'm going to go new branch, create new branch. Okay, so now I've created the new branch, and because it's here, it's an active branch. Okay, so this, like I said, Spider doesn't care about this. GitHub Desktop is doing all the Git integration. Okay, so now as before, I'm going to create that say hello, or sorry, that hello.py file. So I'm going to go new file. I'm going to call this hello.py. Put that in there. I'm going to go ahead and I'm going to do the same thing as before. I'm going to define, say, hello, name, colon, print, do my F string, I go hi, and then I'm going to say name, done. All right. And I'm going to go ahead, I'm going to add in the if name equals main. Go ahead and do say hello name. Whoop. All right, cursor. There we go. All right. What are you complaining about? Undefined. Oh, whoops, sorry. That's why. Awesome people of the hack week. All right. So now that's in there. If I go back to GitHub Desktop, I got a little star here. So I'm going to make sure I save that. So it's saved. I'm going to go back, come on, to GitHub Desktop. And GitHub Desktop is automatically telling me there's a say hello. There's a hello py in here with new changes. So I'm going to say, okay, add hello.py. Okay. So I'm going to commit that. Okay. So now we have the creation of the repository. We had the adding of a git ignore, and I have the addition of the hello. And as before, if I go back to the terminal, okay, I'm sitting in the hack PyCharm, so I'm going to move back one directory, and I'm going to move into the hack. All right, work with me here. CD hack spider. Why? Well, that's weird. All right, let's try. For some reason, never seen that happen before. CD desktop, hack demos. All right, so I'm in the hack demos. I got a hack spider there, so I'm gonna move into the hack.
Eric, yeah, Chung pointed out that you spelled spider wrong previously. Oh no, the files you created SYPDER hack cipher.
Thank you. Thank you. All right.
That's part of the course,
I
Eric.
struggle sometimes. Thank you for that.
They would have
All
driven
right.
you crazy.
Oh my lordy. All right, so since I'm in Windows, I have to do Python -3.9 -m hello. And now I say, hi, awesome hack people, the hack week. All righty. So like before, what I'm going to do now is I'm going to go back. And again, because I'm on Windows, I have to do the pi -3.9. If you're on a Linux platform, you're going to want to do Python 3. All right.
So from here, before you commit the changes, is it possible? I don't actually know in GitHub. I mean, in GitHub Desktop, is it possible to see the brand, yeah. Is there a visual?
compare to branch. Select branch to compare to. I'm in say hello, so I'm going to select main. So main is my current branch. Your branch is up to date with main. So there's everything that's in main is in say hello. If I go to head, this is the number of this is the commits that are in this branch but not in main.
Interesting. So that, I mean, that's in a lot of ways that's the same thing as what you showed in PyCharm.
Yeah. And
It's-
this is kind of the story of IDEs and GUIs. They have a lot of the same stuff, but they change. This is why it's very subjective and why people choose which ones they want. Like, I don't generally use GitHub Desktop because it is a very useful thing, but I find the layout of PyCharm follows
more
the way
consistent
a
with
lot
how you
nicer.
think.
Say that again.
More consistent with how you think.
Exactly. Exactly.
I was part of a Perl community way back when, and you know the historical thing was always the VI Emacs discussion, or Perl and Python. Actually, this very early on when Perl and Python were competing, they hit one of my friend's arguments was Perl works the way that his brain thinks.
Yeah.
And I think that's a really good way to look at it. Each IDE or interface really aligns with how you think.
Yeah, exactly. All right. So if you notice, I have this little .py here. This is a shared objects file that it's unique to Windows. So I'm actually going to go ahead here, preemptively add this to the .gitignore. So I'm going to tell it to ignore files that have an extension of PyC. These are unique to your own computer. So these are something you don't want under version control either. Okay, so I did that. I come back here. So now this should update. Oh, actually, it's not going to update yet because I haven't saved this. So I'm going to save this. So now it's saved. And now the .gitignore is here. You can see automatically the .pyc that was originally here is now gone. And I go update .gitignore. Still can't spell correctly. .gitignore. I'm going to commit that. Okay. So now what I'm going to do is I'm going to switch branches. I'm going to go back to main like I did with the PyCharm demo. So I'll go back to main. And so now you can see this automatically updated. This doesn't have the star.pyc anymore. It doesn't even have the hello py anymore either. So as before, I'm going to purposely create a merge conflict. I'm going to add a file.
Actually, can I ask you a question before you move on?
Yeah.
Because that's interesting to me, because that Spider didn't used to do that before. So you switched to the main branch.
Yeah. In GitHub Desktop, I switched to the main branch. So if I go back to say hello, leave changes. Yeah. So I went back to say hello, and I come back here. My .ignore updated, and my hello py came back.
So is that true? So kind of a dumb question, and I think I know the answer myself, but I find that interesting. The state of the folder has changed to reflect what main looks like at this moment.
Yeah, and let's see.
That's a statement and a question at the same time.
Yep. And so if I go back to the file system, I have the hello and .gitignore. So let's do a little test. I'm going to.
Yes, exactly. I was going to ask you to do that.
I'm going to go to main. So I've switched main. So there you go. The file system.
It's different. That's a good little demonstration right there.
Now, if you have a file in there that's not under version control, it won't change. It'll be completely ignored by Git.
One point is the reason why that happens is under the hood, the .git directory is storing all that data.
Yes.
It still exists. It's just inside of the .git, and it's organized in a way that Git can recreate it with just with a simple instruction to change over.
Yes. All right, so I'm gonna go back. Okay, so now this is up there. As before, I'm gonna create the merge conflict. So I'm gonna make a new file. I'm gonna call this hello.py. I'm gonna save that file. I'm gonna add to this a 1, 2, 3. What's going on there? 3. 1, 2, 3. Of course, just trying to be smart, and I don't like things. Okay, a module that defines the say hello function. Okay. All righty. So I added a doc string. I'm gonna bring GitHub Desktop back, and you can see it automatically. Oh, I forgot. You can see it hasn't shown up here yet because in Spider, I need to save before it shows up. So I'm going to save it. And now it's updated in GitHub Desktop. So you got with Spider, you got to remember you have to save the file before it will register with GitHub Desktop. Okay. So now I'm going to put in here, create hello.py. .py. Okay, I'm going to commit that to main. Okay, so if I do, let's go compare to branch. I want to compare to say hello. So as of right now, my current branch, which I'm in main, is 2 commits behind say hello. So that is, there's 2 commits in say hello that aren't in main. Okay, if I go to a head, so now I have the perspective of say hello. Hello, there's 1 commit in main that is not in say hello.
Okay, I'm gonna ask one more question. This is for me again. Is there a way to see that visually, like the branch? I know that there is a way in VS Code, and I know in PyCharm it shows it. And anybody else who knows.
Yeah, so I'm not a typical GitHub Desktop user. So if any of those out there that know, please chime in. To my knowledge, I don't see functionality to illustrate the timeline, basically, like PyCharm does.
Yeah.
Okay.
How would people do that? Does anybody have a workflow that's like that? That's my preferred workflow. I'm a very visual thinker.
Integrations. Okay, so I'm just getting ahead a little bit. All right, so I'm gonna go ahead. So I'm currently sitting in main, and I want to bring changes from say hello into main. So I'm gonna go branch. I'm gonna merge into current branch, and I'm going to select say hello. So I'm going to try and merge say hello into the main branch. Okay. I'm going to do normal merge commit. Do that. All right. So I have a conflict. Now, GitHub is not an editor. So in order to do this, you have to register an editor with it. So in this case, I already have Atom here, so it's going to try and open an Atom for me to register it. But someone was asking about doing it on the command line, so we can try and do it on the command line here. Will, you willing to help me with this, since I don't normally do it this way?
Yeah, sure.
Right.
And Nick can also help. Nick is smart.
All right, let's see how this goes.
He's an astrophysicist at Smithsonian. So.
All right, so I opened it in command line. Oh. Okay, it didn't do what I was expecting. I was expecting it to do the commands for me.
Yeah, I
but
was expecting that too.
yeah, I'm
That's-
kind of surprised. Help. Okay, so I can still do all that. So what's the, if I do git branch, I'm currently on main. All right, so what's the git command? I know this was supposed to be only through IDEs, but what's the git command here to merge?
So I would go back to, and Nick, please help me, but I'd go back to say hello, and I would do a git. It's already been committed, right?
Everything's committed. I just want to bring say hello in the main.
Yeah, so git push. So I would go to switch back to the say hello branch, and then we'll get a git conflict because main will not be synchronized with say hello.
All right.
So switch
Git
to,
checkout. Is that right?
yep, git checkout space say hello.
Say hello. Okay, so git branch. You'll now
Then it gives you an error.
oh yeah, error. Needs to resolve current index first.
Hello Pi needs merge.
Nick?
I was paying attention. Yep. I think the git merge command would be one, and this is one where I have to like look up. So I think it would be git merge say hello. I think without the
Can you
double
go
dash.
to,
Yeah, I
can you
know.
go to PowerShell? Because I prefer to do it in PowerShell anyway.
Oh, I didn't realize I wasn't in PowerShell. Oh, it only opened it here. So I don't have the option. Well, let's see.
I think if you just close it, you can go to Power. I mean, we're just doing a command line anyway. So
All right.
there we go.
Unless we're in PowerShell. So if I go git branch, I'm currently sitting in main. Okay. So git merge, say hello.
Yep.
Let's live riskly. Fix them in the work tree.
Could you do git status again? Okay, so I think if you open hello.py, yeah, open hello.py.
I don't know what the built-in text editor is for this. All right, so hello.py, where you want to, whoops, come on. Okay, hello.py. Maybe this will let me do it.
Yep, so this will show up the same way as in a
VI
text
or
editor.
any other editor. Yeah, so what happens when you have let me take a second to say this. What happens when you have a merge conflicts? And this is literally what your text file looks like at the moment that you try to resolve. So what you see here is that you have the left arrows and head, and then it goes all the way down till you get the equal signs. So that's saying that your current head has that content inside of it. Below that is what the other file has. Say hello. And there's nothing, sometimes where there's overlap, you'll see many of these heads and content will be stacked up on top of each other. And in reality, all you're doing is cleaning up this file.
Mm-hmm.
So whatever you want the final state of this file to look like is how you resolve it. The nice thing with the editors is that they make it so you can just click arrows and move the content over and visually see it. But that right now, that's the final state, and you have that is effectively resolving your conflicts.
And GitHub Desktop just updated.
Yeah, and if you go to the command line again.
Well, so I like to preface this, even though we were trying to do this on command line, you didn't have to. If you notice that I had this state where it said you got to merge to conflict, and when I went back to Spider, all this stuff updated. So I was able to update those. It had all those merge symbols in there, and I was able to edit the files, save it, and when after I saved it, GitHub Desktop automatically updated. It recognized that we changed the files, went that we have no more conflicts.
Yeah, and
So
what it's
now I
looking
can go
for,
ahead.
all the IDEs, including this GitHub Desktop, what they're looking for are those greater than, less than signs and equal signs. And when you remove those, all of them now say you've resolved your conflicts. So those things are very important.
All right, so I'm gonna go
Those
ahead.
things mean the greater than equal signs.
And I went ahead and continue merged, and now the main is all updated. And so this is exactly where we left off on the pie chart demo. All right, there any questions? I know we're running really late today. So, all righty. I wonder if we should do a quick poll. I really want to do VS Code, but we are really running really late. So I almost want to say to raise a hand if you want to see this demo again in VS Code, and if we get no hands, we move on to GitHub. What do you guys think?
There's a question. First of all, it's a good question. Does anything happen to the say hello branch after the merge? After the merge, at the moment, no. But what you can do is update the say hello branch to align with the main.
Typically, my workflow is, I'll share screen again. Typically, after I create the say hello branch, see if I can do it here. I just go in here and I'm done with it. My work is done. I don't need it anymore. So I just go ahead and I delete it.
Yeah, and you don't have to though.
You don't have to.
So periodically, depending on whether you finish something, there are times where you have a branch that is in active development. A feature set is mature enough that it can be reintroduced back to main branch. And then from there, you continue along with that branch because you may not be complete with the objective. And there's nothing that prevents you from doing that. How you manage your branches is really convention. You know, what is the convention of the team that you're working with? Mm-hmm. Or your own conventions, you know, I mean,
your own housekeeping.
What level of maturity do you have inside of your branch? Are you comfortable with it? Blah, blah, blah.
All righty. All right. So other organizers, you're on board with the hand raise idea, or should we just go ahead into VS Code?
What about surveys? I like surveys better than hand raise.
All right, here, I'll do a quick survey. Great. Survey. All right, demo. Okay, all righty, poll is created. All right, I'm launching the poll now. All righty.
I think, you know what that might suggest? That this could be an opportunity for a breakout session.
I don't want people to miss GitHub. So I think my take right now is almost 90 people are ready to move on, that we move on, but we stick on after to go through VS Code.
Or possibly break out tomorrow. Because I mean, really, we're not supposed to be continuing past 1 o'clock, while people volunteer. 1 o'clock Pacific.
Yeah. Okay, so I'm going to go ahead and move on to GitHub stuff then, so we can start demoing that so everyone is familiar with it, and we can stick on. I say if those that want to see VS Code, we can stick on and continue working in VS Code. If not, we'll figure out some time tomorrow morning to cover it. That sound okay?
Yeah, I see. If we stick after this, and if we have 3 people, that means that everyone who voted yes is sticking around. We won't have to do it tomorrow. If not, then I guess we do. We start like 15 minutes before the actual session, and we try to demonstrate it in VS Code.
Well, let's make that decision at the end of today.
Yeah, okay, sounds good.
All right, then I'm going to go back, share screen. So I'm going to pop back into GitHub demo stuff. All right, so where are my slides? Not that one. That one. Okay, there are my slides. All right, so GitHub. So GitHub, GitHub is a hosting platform that it's predominantly for software, but people often share a lot of hardware there too. It's just a place where we can all collaboratively work on the same project, and everything's under version control. So like I say, like this says, it gives us a location where everyone can work together, and gives us tools for reviewing each other's work, and it creates exposure for your work. So people can just go to GitHub and find various projects. So I'm going to do much like the.
Can I say one other thing that it does?
Yeah, go ahead.
It also it has an opportunity to back up your repository on a non-local space. And we were talking about the .git file, and I can imagine somebody might accidentally go in there and remove the .git file. Maybe they weren't thinking, had a brain freeze or something like that. Well, if you're using GitHub or going to a remote repository, you have this separate location for safety purposes.
Okay, so thank you, Will. Okay, so I want to update the kind of Git branch structure that I showed you. So if you remember, we've been going back and forth to this diagram quite a bit, this main line of development and your branches. When we incorporate GitHub, you essentially have that tree in all these different locations. So for example, if you're collaborating with Plasma Pi has its own repo up on GitHub, and it has its own tree structure with it. And then what you can do is you can fork, and a fork basically makes a copy of what Plasma Pi has and puts it in your own account. Now, your own account has its own tree as well, and it won't automatically sync with Plasma Pi. You have to manually keep it up to date. Okay. And then you still have your local repo. So everything we've been doing so far has been locally done. So locally, you have your own Git branch, Git tree as well. You'll often hear us talk about remotes, and when you're talking about remotes, that's when you basically register one of these cloud-based Git instances with your local one. So if you're in your local repository, both your own fork
and your Plasma Pi are considered remotes. They're external copies of your local code. Okay, so it creates one big workspace. And to interact with it, if you make changes locally and you want to put it up into GitHub, you push it up. So you make your changes and you push it up to GitHub. Or if there's changes up on GitHub and you want them locally, you pull them down. And Git works with is integrating all this too. So much like you had to do merging, the same thing happens every time you do a Git push and pull. Is if you're doing a Git pull, you're bringing changes from up in GitHub and you're merging it into your local stuff. And vice versa with pushing. If I'm pushing, you're taking your local changes and you're merging it with your remote branch or your GitHub version.
I would like to say, when you pull from the cloud, one of the reasons you would pull from the cloud is because somehow your Plasma Pi in the cloud is updating separately. Mm-hmm. It's unusual to have your local repo changing and your cloud. It's not unusual to have Plasma Pi changing and your cloud state changing. Those can be asynchronous.
And with a lot of projects on GitHub, they usually have pushing blocked. So if you have a local copy, you generally don't have the permissions to say push to Plasma Pi. So if you make changes, you don't push it to Plasma Pi. You can pull changes from Plasma Pi, but you can't push it. And that's just a way for us to protect the code. So what you generally do is you do your work locally, and then you push it up to your own account. And then you do what's called a pull request. A pull request is the mechanism in which you merge branches from two different remotes, from two different repositories within GitHub. So this is just a protection mechanism for us. So it's kind of like a gateway. If you want your code to come in here, you go through a pull request and we go through review and go, okay, we like what you have, let's bring it in. Because it's called a pull request because you actually create the request in Plasma Pi. So you're requesting to pull yours into Plasma Pi. So it's from the perspective of Plasma Pi and not the perspective of your own fork.
But yeah, it's not the best name. Yeah. I think GitLab calls it a merge request, which I think works a lot better.
Yeah.
You still get into it's like heat. Which direction is positive?
Yeah. All righty. So any questions on that? Otherwise, I'm going to do a quick walkthrough on GitHub to kind of give you a lay of the land using the Plasma Pi repo. All right. And if you have any questions, like you're all doing a good job of it so far, just throw questions out there and we'll do our best to answer. All right, so Plasma Pi, we have an organization. So if you go GitHub/Plasma Pi, it takes us to our organization page. This is very much like your personal page. And so within here, we have all the repositories that are associated with the Plasma Pi organization. Many of you so far have been seeing the Hack Week repo. So this is the one that most of you have been playing around with, going to resources and getting documents and whatnot. Plasma Pi, the actual Plasma Pi package also sits here. So that's this Plasma Pi repo here. Okay. And when you go to the landing page, you see the code. This is the code that makes up Plasma Pi. So you can go in and say, so this directory is the actual Plasma Pi directory. You go in here, here's the formulary, which we'll be working with extensively tomorrow. And if you go into speeds, this would be all the functionality, all the code associated with the speed functions in the Plasma Pi formulary. Okay. And here's a little navigation. So I'm going to go back to the root directory. And always with GitHub is if you have a README in any directory, it gets rendered down here. Okay, so this is kind of just a README, a summary of Plasma Pi, some useful links we think you all like, how to install Plasma Pi, codes of conducts and events and office hours and things like that. You can also go directly to the documents here. Up here in the right-hand corner, you have a documents. So if you click this, it would actually go to the documentation for Plasma Pi. And this documentation for Plasma Pi also sits within the repo. That document is generated in this subdirectory. Okay. Now, for contributors,
Can you go back through that? You went when you clicked to the documentation, that was fast for me.
sorry.
Okay, so there's an about and a link over there. Okay.
Yeah, there's a link in the top right corner for documents. If you come down to the README, there's also a link down here, right here. I always have, it's always harder to find, so that's why I stick up to the top. So this link will also take you to the documents.
So that link up there that you put, the about, does that exist on all repositories, or is that something that you did for this repository?
I believe you have to set it up, but website, you have to set it up. I don't think that's automatic. You have to set it up, but most repos will have it.
Okay.
Okay. So you go to the docs and the docs page opens up. So this is hosted on a platform called Read the Docs. So you're no longer on GitHub. Okay. And you're automatically directed, you see down here, to the stable branch. So the stable, when you see stable down here, that corresponds to the last release. If you click on this, you can go to the latest, and that corresponds to what's currently in GitHub main. But let's say you're working on version 07, you can come up here, you can click on 07, and it'll take you to the documentation associated with 07. Okay. And all, like as I mentioned previously, all that documentation is generated in this docs directory. Okay. But as a contributor, the places that you'll interact with the most likely issues. So if you have any bugs that you discovered, or if you have a feature that you would like to be added, to the package, or if something doesn't behave logically to you and you think you can improve it and you want to suggest something, you can do that here. So you come here, you hit new issue, and you can pick either one. You get started, and you just write up what for. Okay, and you can add labels to this. You go, this is something that's associated with formulary, so you can tag it. And so that this is how you can let us know about things that you want, or bugs that you find. And as with any open source package, it's only as good as its user and contributor base, because users and contributors will find features and bugs at a much faster rate than the sum of the core developers. That's just always the case. There's more eyes on it, therefore things will progress faster if all of you speak up, basically. And I say that not just in the context of Plasma Pi. I'll say that in context of any open source package. Any software package you use, is always good to let the developers know what's going on. Okay.
Sometimes people might feel like a bit awkward as well, like raising, say if they find a bug but don't feel awkward, we want to be able to know what's like wrong with something so that we can fix them as well.
Yeah, even if you're having much like we've experienced in the last 2 days, if you're having an issue trying to get something set up, something's not working for you, this is also a place where you can bring it up. You can bring it up in the chat, so you can bring it up here, because who knows what the issue you're running across, many people might be facing the same issue. Okay. And so if you have an issue on it and we answer it, people can come and discover it and figure out how to solve it for themselves. I do that constantly with other packages out there.
Hey, Eric, I know for a fact when I first started getting started in collaborative development that I was very scared to raise an issue. I remember I raised an issue with Pint one time, and I raised an issue with another open source software. What kind of guidance can you give on when do you, how do you become mature enough to actually raise an issue? What constitutes a good question?
Every question constitutes a good question. So Will brings up a good point. There are some packages out there that don't have a friendly space, unfortunately. If you browse across GitHub projects and you read through issues and whatnot, sometimes you read some of the responses and it's intimidating. I'm like, this person is not nice. I don't want to deal with this. On Plasma Pi, we don't want anyone to ever feel that way. For us, any issue is a good issue to bring up. We want you to feel safe, come talk about it. That's why we covered the code of conduct yesterday morning. That's why we covered the code of conduct this morning. We want to make sure everyone is comfortable to speak up, ask questions, make suggestions. That helps all of us. It'll help us learn, it'll help you learn. It'll help the overall package become more useful for the entire community.
Yeah, raising an issue with a bug report or an idea of how to improve Plasma Pi, like we tend to think of it as a gift that you're giving us,
Yes.
because it really does help, and we really do appreciate it. And it lets us know that there are people out there who are using Plasma Pi, and that also makes us feel happy about the work that we're doing. So we really do appreciate it.
What if it's not a bug? It's just I don't know how to do something.
We have so on the GitHub page, there's a discussions tab, and that is a good place to ask questions. We also have an Element chat room, which I can put the link to in the chat. And on Thursdays at 3 p.m. Eastern, we have office hours. So there are lots of places to stop by. We tend to be a little bit slow responding to emails, though, unfortunately. But
posting either in issues or discussions is a great place because as developers of Plasma Pi, GitHub gives us a notification center. So whenever a discussion is open or an issue is created or someone comments, we have notifications. We see these, we spend a lot more time here. At least I do. I spend a lot more time here than I even do in my Gmail.
I 100% concur. You can also subscribe to other notifications. If you want to be made aware of notifications, you can subscribe to them.
Yeah, so if we go back, oh, I can't do it. All right, so if you go watch, so if you go to the Plasma Pi repository, you go to watch, you click under here, and you can select how you want to be notified. So for me, I'm getting all activity, or you can customize it to only get certain type of activity if you want to see what's going on in the package. Okay.
And also to particular issues and pull requests and things.
Typically, if you, I can't remember. I know if you open an issue, you will automatically get notifications to it. I can't remember if you automatically get notifications if you just comment on an issue. I don't remember if that's true or not.
I think you do, but yeah.
All right, so the next place you live is pull requests. Pull request, unlike issues and discussions, which is, they're both kind of like discussions. One's oriented more towards bugs and features, and the other one is open more like general discussions. Pull request is where you actually request to merge in code. So let's do this most recent one, which Nick had opened. So in this case, he has a branch sitting here in his fork, in his own account, that he's asking to get merged in the main. So even us as the core developers, we don't create our own branches on Plasmify. We create it on our own repositories, and then we request to have them pulled into the main repository. And so in here, you open it up, you give a little description, and so you have this conversation tab where you have a conversation about the code and what's going on. So we can go back and forth. We have a bunch of what's called continuous integrations, or CIs. So this is things that are testing, that are running our tests, checking the quality of our code, building our documentation. So this is make sure that everything is in order before it's merged. And so if you ever open a pull request and you start seeing a whole bunch of red X's, don't worry about it. It happens every single time. And as the developers, us, we will work with you to get all those reds turned green. It's typical. I get reds all the time when I open up pull requests.
Follow on from yesterday. If you open a pull request and you get all ticked straight away, then you've done something wrong.
Nick, you're gonna say something?
Oh yeah. Usually the first one to look at is the CI/Python, and then usually it'll be the 3.10. And doing the Python tests, those ones are the most important to get passing. So if you click on details, that will usually show the output of the tests. And it will, if you click on, it'll often usually pop up to when a test didn't pass. And in this case, everything did because I didn't change that much. But that's the first one to go to. All right.
That's a documentation failure. Okay, so if I go back. All right, yeah, the one that will almost always fail when you first put in a pull request will be this changelog entry. That almost always fails because no one creates a changelog before they do a pull request. Again, this is stuff that will help you with when you do a pull request. So don't worry if you see red, we'll get you squared up. So this is the main kind of discussion area. Then you have commit. So this just shows the commits. So in this case, these would be the commits that exist in Nick's branch that does not exist in the main branch. Okay. Checks. This is another view on the CIs that we were just talking about. And then there's files. These are the files that are actually changed. So in this case, Nick just removed this Plasmapy 08 down at the bottom and added this space here. Why is that not working? You did put a pair there. All right. I don't know why, but so this is how you comment. So I saw a period here. That doesn't make sense to me. So I'm going to suggest to remove it because I have no clue what that is. And I'm going to go, what is this? What is this? It doesn't look right to me. And I can add a comment. And so he will see my review. And if he agrees with me, he can go ahead and just add it. If he doesn't agree with me, he can respond to me and go, Eric, oh, this is what it actually is. And he can send me a link to why it's there. And therefore, I get educated as well. Or we fix a potential bug before it gets in the main. All right. I think that is all I was going to do with a general walkthrough. Next, I was going to go through the process of creating a repo and start integrating it with my local stuff. Since we are really short on time, I'm just going to do this through the PyCharm side of things, because it shares a lot of the same commands that you've seen with the previous demos. Are there any questions? All righty. I actually, Will and Nick, do you want to do the SSH stuff first?
I wonder if you'd want to do that tomorrow.
Yeah, it's going to be ambitious to try and do it today.
Okay, then we'll do that tomorrow. All right, so what I'm going to do is I'm going to go back to the Plasma Pi organization. I'm going to go ahead and I'm going to create a new repository. So I'm going to go ahead here. I'm going to go new repository, and I'm going to call this the 2022 hack demo. Okay.
Should you create it? Should you create it in Plasma Pi, or should you create it in your own directory? This is going to be for everybody to use, though, in this case.
Exactly. So if it's just your package, you just create it in your own account. Okay. If this is a package that's intended to be, so for example, this is for demonstration purposes, but if this is going to be something that is supposed to be owned by Plasma Pi, then I create it here. Okay. Okay. Demo repo for the 2022 hack week. Okay. I will go ahead and have a README automatically added to it. I'm going to add just a simple license to it, and I'll create the repo. All righty, so now we have a simple repo in the Plasma Pi account that's called 22 hack demo. So if you go back to the organization and you come down to the repositories, you'll see that it's sitting there. So you can go ahead and you can go to that hack demo. Okay. So now I'm a user outside of Plasma Pi. I really like this project and I want to start participating in it. And I want to start working on some new functionality. The first thing you do is you come up here and you click fork. When you click that fork, you'll end up creating a copy of that repo in your own account. So I have different organizations, so I can select where I want it, but I want to put it into my personal account. So, okay, this comes up, I go, okay, I want this, and I create the fork. Okay, so now I have this 2022 hack demo sitting in my personal account, but it is labeled that this was forked from the 2022 repo, the Plasma Pi version of it. Okay, so now I have my own copy. So now basically, where are we? I am in, oh, here, sorry. I created a repo here sitting in Plasma Pi and I forked it. And so now I have a copy of that repo sitting in my own account. So these are the two that exist currently. I don't have a local one that exists yet. So now I want to create a local one because, well, I'd rather code on my local machine than try and code up in GitHub. My editors locally are much better than the editors in GitHub. Okay, so I need to get a copy of it on my local machine. So I'm going to go back to PyCharm. Now, one of the things I've already done here, this is the stuff that you heard Nick and Will and I just talking right now that we're kind of skipping over right now. If you go to settings, okay, come on. All right, if you go to settings, you search GitHub, okay? Here, you have to register your GitHub account. So what you'll end up doing is you click add, and you're going to want to log in with a token. And Nick or Will, can you put the can you find the GitHub instructions about generating a token and put it in the chat? And
Okay.
so what happened is you'll log in with a token, you'll go back to GitHub, and you'll generate one, and you put that here. And that's what will give PyCharm authorization to communicate with GitHub. Okay.
You had two options there. Log in with
This is legacy. GitHub doesn't allow login like this anymore.
Okay, so that one got it.
Yeah. No, well, it just worked for okay. Sign in might work. I've had issues with it in the past. The token is usually the safer way to do it. That's my own experience. Okay, so once you hear, so I'm still sitting in that demo repo I had before, but now what I want to do now is I want to call what's cloning. Cloning will copy my GitHub repo to my local machine. So I'll go up to Git up here, and I'll go down to clone. I'll hit clone, and I want to, since I already logged into GitHub, I want to go to my GitHub account, and it shows me all the places I can clone from. So I'm specifically want the 2022 hack demo. That's the one I want. You'll see these other ones have, so like this one has Plasma Pi /Suli, because this one is sitting in Plasma Pi. If I don't have that, if I don't have this name /, then that's in my own repository, my own GitHub repository. So I want to clone this 2022 hack demo. So I'm going to clone that, and I want to select where to go. I don't want it in this current location. So I'm going to browse for a different location for this. I'm going to go back to my home directory. I want to go back to desktop. I'm going to go into the hack demos, and I'm going to put it in here. And I believe, okay, let's see if I get this right. I believe I have to name the folder that will be it. So hack demo, okay. I want that one, and I go ahead and I click clone. I want to trust the project, and I'm going to open it in this window. All right, there we go. So now I've cloned what is up on GitHub. So now I had, let's go back to this guy. I had created the repository here on Plasma Pi. I had forked a copy over to my own GitHub repository, and I have just cloned my GitHub repository to my local machine. So I've just done this pathway. Okay. And double check, did I get that right? Oops. Yep. So if I go to my file browser, I now have in the hack demos folder, I have a copy of the 2022 hack demo. In there has everything that was a part of what's up on GitHub. Okay. All right. And so now if you notice, it takes the same naming scheme of what's already up on GitHub. So now my default branch is the main branch. Okay. Now I'm going to introduce a concept of remotes. I've already mentioned it once before, but in here I can go Git, and I'll go to, where are you? Manage remotes. Okay. So as of right now, since I cloned this for my own GitHub repository, I have one remote. This is, a remote is an external copy of the repo that you have locally. I hope I said that clear enough. But you can have multiple remotes. So this one is pointing to my GitHub account. And you can choose what other whatever naming scheme you can. Origin is very common. That's where you've done the original clone from. Because I know this is a forked copy of a different one, I like naming this fork. So in my mind, I go, okay, that's the fork of what the original thing was. And I can add additional repos. So in this case, I'm gonna edit this. I want to copy this URL, because what I want to do is I'm going to add a new remote, but this remote is going to be specifically to Plasma Pi. Okay, and I'm gonna name this Plasma Pi. This is just how I like to work. You can name these remotes whatever you want. So whatever helps you keep track of it, you can name it how you like. Okay, so now I'm going to add that. So now I have a new remote. So let's say if I look here,
Before you might be talking about it now, but why would you want to point to both remotes? I think you can go back to your picture and motivate that.
Okay, why do I want to do remotes? It depends on your workflow. Typically Plasma Pi, this side, since this is the main repository, this guy will almost be always ahead of everything else. There will always be changes over here that don't exist in your fork or your own local repo. And you won't ever see that here unless you go to request. So you have to keep on track that there are changes here and you want to bring them over. Okay. I like connecting both remotes because what will happen in my system, let's bring this little dialog back up. It sees here, you want to do a process called a fetch. So a fetch, so as soon as you add a remote, you want to do a process of a fetch, and that basically will go out and ping all your remotes and check and see what their status is and update the logs for you. So I'm going to do a fetch, and that goes out to both repos, look to see what's there, and it'll update the dialog for me. So now it shows, oh, there's a Plasma Pi main out there, which I didn't have before. Okay. And I got a fork main, and then I have my local main, and my local main is pointing to my fork main. So let's do a thing where I'm going to go back to GitHub. I'm going to go back to GitHub. I'm going to go back to the original Plasma Pi repository, and I'm going to go ahead and I'm going to create a new branch. I'm going to call this idea A. Okay. And I'm going to go ahead and create this branch. Okay. Did you create idea A? There we go. So idea A is created. Okay. So now something happened over in Plasma Pi. Okay. But if I wasn't paying attention, I wouldn't know that there was a change there, because the change is not reflected in my own fork. My fork doesn't have this idea A in it. So if I go back to PyCharm and I do another fetch, which is always a good thing, regular fetches is always a good thing to do, trying to stay up to date. So now what will happen is it tells me, oh, there's a new branch being worked on there. Additionally, if there's a change to main, so let's go do that real quick. So if I go back to the repository and I go back to main, okay, I'm going to expand this demo repo for Hack Week. Okay. Hi, awesome people of the Hack Week. week. All right, so I edited the main, and I'm going to go ahead and commit it straight here on GitHub. This is generally not a workflow you do. We generally have protection, so you can't do this, but this is for demonstration purposes. Okay.
If you want to fix awesome, you spelled it wrong.
Sigh. Awesome. All right, so I'm going to commit those directly to main. You can choose to do it through a pull request, but right now I'm just going to commit it straight to main. So I'm going to commit those changes. Okay, so now main is updated. And so if I go back to my local copy, I don't know anything yet. So I'm going to do a fetch. So I do a fetch. Oh. That's why. So, okay. What I expect to happen didn't happen. There's a reason why. So currently only this fork or only this branch exists locally. One of the things I like to do is I'll go to Plasma Pi main and I'll do a new branch from that. And I'll call this main from Plasma Pi, and I'll create that. Okay. So now
Could you have done a pull? So this was going to be my question earlier, and this is helpful for me. So now we're
I
at the
just
part.
did a poll.
Yeah, but you could. So if you go back to your picture, the image, because this is hard to really see what you're doing for me.
Mm-hmm.
But you're in your picture.
Yeah.
What's happening is you have a disconnect from your cloud. Plasma Pi and Plasma Pi at me don't share that branch.
Correct.
You could do a pull from Plasma Pi, and my local repo would reflect Plasma Pi. And you could push that back to Plasma Pi at me.
Yeah. So what you saw me just do is I originally cloned Plasma Pi at me, and I only had one branch down here on my local repo that was main, that is linked to the main in my copy of Plasma Pi, or the hack demo repo. Okay. What I just did when I did this Plasma Pi main new branch, what I essentially did is I looked up here at Plasma Pi's main. I created a new branch called main from Plasma Pi locally that is a copy of what was up here in the Plasma Pi GitHub.
Yeah, could you have just kept it main? Is it not possible to synchronize?
You can do that. The reason why I haven't done that is because I already have a main and it's already pointing to my fork.
Right, which means that it's not synchronized.
Yeah.
But you could, depending on your workflow, you've chosen a particular workflow and you're teaching that workflow.
Yeah.
But that workflow basically says that main is not being synchronized between your cloud Plasma Pi and Plasma Pi out there. I mean, periodically do you just go create a new fork?
No. So what will happen is I created this new. I never maintain the main on my fork because I don't ever make. I always make new branches from Plasma Pi's main. So I'm always making branches from the newest version of Plasma Pi.
And you never push it back to your main.
I do push it back to my main as a different branch. Sorry,
Yeah,
I do push it. I don't.
That's not pushing it back to main.
No, sorry. I misspoke. I don't push it to main. I could. I don't. I just push a new branch to my fork.
Oh, want to do a time check that we have about -5 minutes left.
I agree. We're hitting a lot of heavy stuff at the very end of a session.
Yeah.
So there's a good place to wrap up.
we did this in an hour and a half last year. So, I
Which
don't
would be
know.
worse. Which would be worse. I think this is heavy stuff.
This is heavy stuff. Yeah. Okay. So let me do. Okay, so I'm currently in the main from Plasma Pi, but it's not linked to the Plasma Pi's main yet. So what I like to do is I go to terminal, you do git branch minus VB, it shows me the branches that exist locally. Right now, the original main is pointing to fork main, but my main from Plasma Pi is not. So you can do git branch set upstream to equals Plasma Pi / main. And what that will do is it will actually link this branch main from Plasma Pi to the main branch on Plasma Pi. Do that. I go back to VB and you see now it's to get branch VB. Now you can see that it's pointing to that. You can also see that in the dialog. Now it's pointing here to Plasma Pi main. So what I was trying to demo before, so I'm going to go back to GitHub. I'm going to go back and re-edit this file. I'm going to add some more exclamation points. Okay. Needs more cowbell. Okay, I'm going to commit that directly to main. Okay, so now if I go back to PyCharm, I open up my little branch dialog again, and I do fetch. This guy now has a little arrow on it. That is telling me my local copy that is synced with Plasma Pi's main is out of date. This is my cue that something has changed over there that I don't have yet. So what I do is I can go git update, and this basically pulls down what is from Plasma Pi's main into my copy locally. Okay. Will, does that address some of the questions you had and how I keep them synced?
I really think we should probably start on this tomorrow. The answer is no, I wasn't. I'm starting to think about my next. I'm starting to think about my next meeting because I just got a meeting invite to something, and we're hitting the end of the session. So
Okay, fair enough. Nick, you have opinions? Do you want me to go through a branch and a pull request, or do you want to reserve this for first thing tomorrow?
We should do this tomorrow.
You want to put a poll out there and check everyone?
I think we should do this tomorrow. I think
we should stick to our time.
Yeah.
It's very important to be considerate of other people's time.
Okay. All right, fair enough. Then I can pick up with this thing first thing tomorrow morning. But I will, if people want to stick on and ask questions, I'll stick around and answer questions.
Yep, I'll be around for a bit longer too.
I'll leave closeout for you, Nick.
Okay. So yeah, thank you for sticking around to the end of day 2. And tomorrow we'll continue with Git and GitHub and go through the process of contributing a pull request, including a demo for that, and then work on a hack formulary. So yeah, we'll stick around for a bit longer. And again, thank you.
Thanks, Eric. This was awesome.
Not a problem. Thank you. Sorry for everyone for kind of the little road bumps that we had. I hope it at least is somewhat enlightening.
Definitely.
Wow.
I'm going to go ahead and stop the recording.
That sounds good.